Hi everyone, this is Ankita and Antonio, engineers from Reliability Infra at Meta, here to speak with you about dependency safety for distributed systems. Through this talk, we want to emphasize the importance of end-to-end reliability of our products. Meta turned 20 this year, and in this time, the company has grown from one product to many user-facing apps, launched new hardware on multiverse, and has now launched cutting-edge AI models. Our infrastructure has grown 4 times in the last 5 years, and it will continue to grow with newer trends in the industry. On a daily basis, Meta serves 3 billion users. But what makes this possible? Thousands of microservices running on millions of machines across our data centers, handling multi-trillion requests per day. It is the tip of the iceberg because we are not even complete in terms of instrumenting all the connections between these microservices. This is also a snapshot of production data, a zoomed in view at 5,000 feet showing how services operate in a single rack of servers. It is just one piece of the puzzle. The end-to-end journey for every user request originating from our apps traverses hundreds of hops across Meta's distributed architecture, such as client libraries, privacy and security frameworks, microservices, configuration files, and hardware, serving every single request coming in from 3 billion users every day. We have thousands of dependencies operating at each node of user request journey. These dependencies are interconnected, making our infra a massive, tightly coupled graph. But why do we care about dependency safety so much? Dependencies are the fourth leading cause of outages in our company. Engineering surveys highlight dependencies as one of the top barriers for our engineers to do reliability work. This makes them extremely costly in terms of user engagement, rendering our apps unable for people, millions of people, depending on our products every day. Debugging every outage also costs many hours and hence slows down the developers. This in turn slows down the rollout of new features and fixes to our end users, affecting overall business efficiency. We believe that much of dependency-related risks can be avoided, but limited visibility, insights, and tooling have made it really difficult to get ahead of the growing issue. So how are we approaching this problem? With a three-way mechanism, being proactive for prevention, help teams to understand their dependency landscape and mitigate risks before it goes to production. Reactive mode for effective incident management to quickly identify dependency issues and actions required to mitigate outages. And lastly, federation, setting high standards of dependency reliability across the company, because it is not just gonna take one village to get this under control. We are going to use the same sequence to proceed in our talk. Let's hear more from Antonio on the best practices for preventing dependency outages.
Thank you, Ankita, for putting our infrastructure in perspective. My name is Antonio. I'm a production engineer at Meta, and I've been working on dependency management in some shape or form for the past 3 to 4 years. The complexity of our infrastructure is truly astonishing. It really isn't surprising anymore when failures in one part of our stack quickly percolate and starts affecting seemingly random parts of it. What we want to do in proactive dependency safety is make sure that doesn't happen anymore. We want to bolster the containment properties of our system so outages are well contained. But at the same time, we want to make sure that whenever outages do take offline large swaths of our infra, there's a clear path towards recovery. Out of those two things, we've made a lot of progress in the recovery front, and that's what I'll be focusing on for the rest of this section. When we think about proactive dependency safety and recovery, the thing that we're concerned about the most is cycles. We've experienced several close calls throughout the years with dependency cycles, and we know how dangerous they can be from firsthand. And so just to give you an example of how this plays out, we had an outage a year ago where one of our backend services was experiencing overload. This backend service powers binary downloads in our fleet. And so we decided that, okay, if it's overload, we can throw capacity at the problem to quickly mitigate. And that's kind of what we did. We went to our terminal, we typed in the commands to get more capacity, but then when we tried to use the capacity, the command failed. After scratching our heads for a while, we figured it out. Oh, of course we can't resize our job and increase the number of instances. In order to do that, we actually need binary downloads to be working. And so we were in a chicken and egg kind of problem in the outage. Fortunately, this outage we're well prepared to handle. And so we knew how to escape that circular dependency. We had an escape hatch. But when we went looking for other places in our infrastructure that could have circular dependencies, we basically found them everywhere. And so we really needed to find a balanced approach for addressing cycles, one that would mitigate most of the risk without causing a bunch of churn to our infra teams. After a lot of back and forth, a lot of trial and error with different teams at different parts of the stack, we landed on the following policy. Ideally, if you can remove the dependency that's causing a cycle, you should just do that. But if for some reason this is too expensive or is just not feasible, then we suggest one of two things. First, if the cycle is coming from nice to have functionality, then it should be made best effort. If instead the cycle is coming from critical piece of functionality, then you should be investing in escape hatches that would allow us to sidestep the dependency during recovery. In order for our policy to work, there needs to be continuous validation. Otherwise, teams will put in effort to address the risk of a cycle just for it to come back again in 1 month, 6 months, or a year. If we were to picture how our policy looks like in action, just take as an example the toy graph that we have on the slide. Right now, if you squint, you can see that there's cycles in this graph. And so what we want to do as part of our policy is go from here to here. You'll notice that some of the arrows have been removed and others have been grayed out to symbolize that they're now best effort when there's an escape hatch available. All in all, in this second graph, there's no longer any problematic cycles. As I mentioned before, a critical piece of the puzzle is continuous validation. And so we decided to invest and create our own testing framework called Beljar that makes this very straightforward for teams to do. We've already discussed Beljar in another at-scale presentation back in 2022 from two of my coworkers, Jie Huang and Chris Bunn, and that was a great presentation that went in depth. What I want to do now is I'll just cover it at a high level and talk a lot more about the gaps we've seen since then. And so let's do that. Beljar is a testing framework that takes healthy hosts in our fleet and degrades them to simulate the types of outages where circular dependencies are problematic. Under these conditions, Beljar tries to start up your service. If it's able to do so, then happy days. You've proven that cycles are a non-issue for your service. If, however, the test fails, then you know that you need to do some work in order to mitigate the risk. Back when Chris and Jia did the talk in 2022, we were feeling pretty confident that we had mitigated the risk of cycles in one part of our stack, the control plane. But that didn't last more than 6 or 8 months. We were humbled in a production incident. There, one of the services that had a Beljar test was having a hard time recovering due to circular dependencies. And this is kind of mind-boggling for us. If the test is passing in production, how come we can't recover from this outage? And so we had a lot of work to do after to make sure that this didn't happen again. And so we had a lot of investigations and a lot of follow-ups. And that's when we realized that Beljar tests have a coverage problem. Beljar is pretty good at surfacing any of your startup dependencies because it automates this process for service owners. What Beljar isn't well equipped to handle is runtime dependencies. What happens once you start exercising different endpoints? And the reason why Beljar is not well equipped to do this is because it relies on test authors to write a bunch of validation. And when we tried to quantify how many validations teams were writing, how much of their code they were covering with the test, we realized it was pretty poor, sub 50% for most of the cases. And so we were really at risk of having a repeat incident where one of our systems in the control plane would have been able to recover due to cycles just because their Beljar test wasn't validating enough. At the same time, we realized we can't force teams to reach 100% test coverage. That's impossible. That's going to be basically chasing a moving target. So we needed to get smart on how we address this. That's when we decided that we're going to leverage production data in order to guide coverage in Belger tests. At Meta, we have several data sets available that capture the connections different services are making in real time, basically. And we decided that we wanted to tailor these data sets in order to analyze the different dependencies that we were seeing and see which one of those might be risky to a particular service. And risk here can mean different things, including introducing a dependency cycle. Whenever we detect one of these risky dependencies, we now flag it to teams directly and tell them, hey, we've noticed that your service is depending on this, and this might cause a cycle. And so we really need you to include this code path under your Belger test. And that's kind of how we're approaching the smart way of increasing Belger test coverage. One that doesn't tell teams to go for 100%, but that also doesn't basically leave the status quo. It's a nice middle ground that we found. And teams are reacting positively to this approach. And so we're excited to take it further. And with that, I'm going to hand it over to Ankita, who will be talking about the reactive side of dependency safety.
Thank you, Antonio, for highlighting how we can all go a step further during development phase itself to ensure a seamless experience for our users. But despite our best efforts to prevent all bad things from going into production, outages still happen, disrupting not just end users but also developers. But what can we do in this situation? What is the fastest way to reduce blast radius? How do we get the situation under control? Incident response requires making decisions in the smallest amount of time to mitigate outages. About 4 years back, 50% issues on some of our biggest user apps were blamed to dependencies. And there was no way to even figure out which part of the user journey was broken. At the same time, we also started seeing user engagement impact. Users were not happy with our apps. And our solution to handle this problem helped us cut down incident response time by 50%. This was a big win and improvement to our existing methods. Let's see how we made that happen. We needed to identify the critical services powering a user interaction, detect when they were unavailable, and help diagnose issues faster in order to limit the downtime that our customers experienced and keep both our users and developers happy. For the first step of this effort, we built the dependency graph. But how? We needed context propagation. Context is any relevant information in the span of a user interaction with our apps. We identified the most critical user interactions on the app, added a bunch of instrumentation on the front end. This instrumentation helps detect when user interactions are broken or down. We then plumbed these interaction IDs into our backend tracing infrastructure across all service calls with our distributed tracing system. That provides observability into the execution of requests in real time. And voila, we had a service dependency graph end to end, from devices all the way to hardware, enabling us to identify dependencies for the most critical user interactions. For faster detection, we need real-time metrics. With context propagation and enhanced instrumentation, we also enabled real-time monitoring of the success and failure rates of these user interactions. And along with that, we also instrumented and monitored dependencies across the fleet. Now, we could monitor not only the individual apps and the user interactions, but every individual piece of the user journey at the lowest level of granularity and get alerted within minutes when a user interaction was broken or a service went down. As you can see in the diagram, interaction ID 10 is showing a broken user experience in real time. And that is what our on-calls monitor day in and out to jump on the issues ASAP. Last step, connecting the dots for faster diagnostics. We have established that every product in our company has a very huge service dependency graph. We also needed real-time metrics. What is next is to be able to trace this user interaction from the top node all the way down to the reef node and figure out which node in this dependency tree is impacted at any given time and why. What is red and what is green? And that is what we built. A comprehensive diagnostic surface that provides visibility on live events inside our infra via event discovery and correlations. This tool enables us to fetch service dependency graphs for any product or microservice in this company. And on this graph, we can enable overlays for relevant metrics and events to diagnose the root cause of the outages. Observing anomalies in metrics such as error rates, latencies, missing data, and in-progress events such as outages in a related system, data center drain tests, end up providing a holistic view to the developer on where something could be going wrong. This service dependency graph not only enables us to correlate incidents, but also helps us to narrow down the bad diffs and deployments in real time. To recap, let me show you how everything looks in production. We identified and instrumented the most critical user interactions on the app. This instrumentation helps detect when user interactions are broken or down. We then plumb these interaction IDs into our end-to-end distributed tracing system that provides observability into the execution of requests in real time. And now, if user-facing errors spike in our front-end instrumentation, we can quickly detect that something has gone wrong, and we have enough tracing to root cause the issue to a particular service that's failing. From here on, the app on calls can work with the backend service owners on how to mitigate the problem. This end-to-end tracing from the device all the way down to the data stores enabled us to cut down time to mitigate outages by 50%. We spoke about being proactive and about taking actions after the incident takes place. But our reactive and proactive programs have touched only a small subset of our entire architecture and product line. Going forwards, we need to scale both of these so that they touch all user-facing products and thousands of services that exist at Meta. For scaling at Meta, we have established a bunch of company-wide programs, service reliability reviews, that enable the existing and new service owners and reliability experts across the company to deep dive in the architecture and setups based on a predefined template. There are two main benefits to these deep dives. We get to learn about service architecture and limits and be aware of the challenges that they face on a day-to-day basis. The services, on the other hand, get uplifted in their processes and best practices from the experts across the company. It's a win-win situation. Everyone gets to learn from everyone. It's not just the dependency teams that we hold accountable, but we also hold product reliability reviews, where all the major end user products bring forth their current and future reliability plans for minimizing blast radius and mitigating risks from the complex dependency graph invoked in their user requests. And lastly, we have set up a reliability maturity model where we have defined a path forward for the dependency owners to adopt best practices for improving their reliability. Over to Antonio to shed some light on the same.
Thanks, Ankita. Ankita just spoke about how we could leverage reliability reviews to federate some of the work we've been doing in dependency safety. Another tool that we're leveraging is called the Reliability Program Maturity Model. It's a mouthful to say, but its essence is actually quite simple. It presents to teams a roadmap they can follow in order to up-level their reliability. It does this across different dimensions. Think on-call health, SLOs, testing. In this tool, we created a new dimension just for dependency safety. And you can imagine that we'd included in the roadmap onboarding or using a lot of the tools that we've been discussing throughout this entire presentation. We've seen this tool getting more and more adoption in different teams in the company, so we're very excited to keep investing in it to federate a lot more of our work going forward. All right, so far we've been focused on talking about the present, what we have been doing for the past year or two. But now it's time for us to talk about the future. We started the presentation by shedding some light around the complexity of our infrastructure and how that is causing us a bunch of problems and toil. It's increasing time to mitigate of outages because we're having a hard time navigating the dependency maze. It's also making recovery from certain outages impossible due to those pesky circular dependencies. But we now sit on a critical juncture. We know that our infrastructure will be growing at an accelerated pace going forward. We expect, I think, around a 4 to 5x increase over the next 4 to 5 years. That's quite a lot. Whatever the dependency problem looks like today is going to look a lot worse by that time. And so we really need to make sure that the tooling that we are building will work for our infra of tomorrow. We know this challenge isn't exclusive to Meta. Companies of all shapes or forms struggle with dependencies. And we're very excited to learn about how you've been dealing with the problem, which set of assumptions you had to make, and how your infra has influenced your roadmaps. And with that, we leave you. Thank you for watching.